Alright, so you should have the relationship between two categorical variables notes in front of you. So up until this point, we've only focused on having one categorical variable. So now we're going to talk about how we look at things when we have two categorical variables instead. If you are wanting to look at the book, that's going to be in chapter 22 for the Chisquared Test for independence that you'll be looking at. But we're going to go ahead and start by looking at an example to see where we actually see this kind of example show up. So probably many of you have heard of March Madness, or the NCAA men's basketball tournament. It's a very important time of year here in the Cincinnati area because there's many different teams to root for, a lot of them that show up in the tournament year after year. So maybe we would like to know, who do our NKU students root for? So I took a random sample of 800 NKU students and I asked them to choose between rooting for one of the following teams, either the University of Kentucky, Louisville, or Cincinnati. In addition, I also recorded what state the student is from. So first, still going back to our who, what, when notes, we've got to figure out who our population is and what variables we actually have. So who is my population? So let's talk about where we get our sample from and figure out maybe if we can make it bigger. So we have 800 NKU students. Our goal is to find out who NKU students root for. So is NKU students the population based upon our sample as well? Yep, so I mean we're taking a sample of NKU students. Nothing we should really be worried about here. So I mean part of here, so the goal is NKU students. They want to see who do NKU students root for. We don't have any bias known anyway with our sample, so we should be okay with it being all NKU students. What variables were recorded? So again, so if we have a student in front of us, what information are we recording from them? Well, we're getting who they root for. So they get to choose between UK, Louisville, and UC. So is that quantitative or categorical? All right, so that one's categorical. And then we're also getting what state they are from. What state you're from, what kind of variable is that? Right, so that's also categorical variables. So notice now we have two categorical variables. That's why we would be in this set of notes. So when we have two categorical variables, we like to be able to look at both of them. So we're going to summarize them in a little bit different of a way. This table that we have below is what's called a contingency table. And we're going to first talk by looking at it and seeing if we understand what the numbers represent. So we have what state the student is from, so we classify it either as Kentucky, Ohio, or other. And then we had which team they would root for between the three, either UC, Louisville, or UK. And then we have some numbers, we have some totals. So let's talk about what some of these different numbers represent. First, we're going to talk about the numbers here in the middle, the ones that are unbolded here. And so for example, 105 is one of those numbers in here that's not bolded. So what would that 105 tell me? So that's my number of NKU students sampled. Who were from Ohio. I'm sorry, who were from Kentucky. And root for Louisville. So the numbers there in the middle, we get where they're from and who they root for. So we get both things without one number. Next, let's talk about one of the numbers along down here at the bottom. So the column totals is what that number would actually be. So like for example, to 363. So if I look at that 363, it's ignoring what states. We've kind of combined across state. So we're just looking at what team they root for and how many NKU students root for that team. So this tells us the number of NKU students who rooted for UK. Then we have what we call our row total, or the numbers here, the 400, 300, and the 100. So for example, I chose the 100 for us to look at here. So what does that 100 tell us? So that's our number of NKU students sampled. From, in a sense, an other state, or you could think from not Kentucky or Ohio. And then finally, this 800, what does that represent? That's just our total number of NKU students sampled. So if we're looking at our picture back up here, so I'm going to highlight. If I look at these numbers here in the middle, these take into account both variables. They take into account where the student is from as well as who they root for. If we look at our column totals, the ones down here, these would look at just the root for variable. So we're ignoring state if we're looking at those numbers. If we look at the row totals for our numbers over here, those look at just state. And ignore the other variable. And then we finally have the 800, which is just a total. It ignores all the other variables. Doesn't even take into account any of just total number of students that we had. So this table is a nice quick way of summarizing both variables. It also allows us to look at the individual variables if we so choose. So how is this really different from what we've been already doing? Well, the first part is probably obvious. Before, we only had one categorical variable. And now we have two. What's also nice about looking at two, though, is this first time I was sort of bad about one. When we only did one categorical variable, focus was on one category. Let me explain what I mean by that by going back to our example here. So let's suppose I was just going to look at who a team rooted for. So which team was rooted for. I would have to pick one of the three. So I might calculate the proportion that picked UK. But then the other two would be kind of ignored. Or I could look at the proportion that picked Louisville, but the other two would be ignored. So I had to pick one of those options to focus on. Now what's good is we can actually look at all of the options, not have to just focus on one anymore. And it allows us to do that at the same time. And so in addition to getting to look at more than just one category, we're going to eventually want to find out if there's a relationship between our two variables. So in order to do this, we have to figure out which variable is which. We have what's called an independent or an explanatory variable, and we have what's called a dependent, or generally called a response variable. And I generally like to start with the response variable because that's what you generally know first. So this is the outcome of interest. What are you really the most interested in? And then our independent, or the explanatory variable up here, is thought to partially explain the response variable. So looking at our two variables, we have the team you root for as well as the state you're from. Let's try to figure out which one would be which. Do you think where you're from explains who you root for, or that who you root for explains where you're from? All right, so let's see if your gut instinct was right. So our response variable, or the one that we're interested in. So let's actually go back and look at what our example even says. We're trying to figure out who do our NKU students root for. That's really what we want to know. That should be what our response variable is. Now what might explain who you root for is the state you are from. Maybe we want to see, is there a relationship between who you root for and what state you are from? Right, now that we know which variable is which, let's talk about how we're going to summarize our variables now. So the first way we like to do this is through what's called the row percentages or the row proportions. So we don't like to just look at the counts because it's not a very fair comparison. Because what we want to make sure we take into account when we do this is notice that, there's a different number of students from each of the different states we covered. So just looking at the raw numbers by themselves aren't a really fair comparison. Just looking at those numbers, I can't tell you what they really mean. But as soon as I look at percentages, I understand percentages much better, and so I can do that much more easily. So we're going to calculate what's called a row percent. So first I'm going to explain why I do a row percent. So when I organize my data, I always like to organize it the same way. Over here in my rows is where I'm going to put my explanatory variable. And then in the columns is where I like to put my response variable. And since I always organize my data that same way, that's why I'm going to focus on just the row percentages. And when we do row percents, what that's going to mean is that each row should add up to 100%. And we're actually going to not do anything with that total row because it doesn't really make sense for what we're trying to show here. Alright, so how a row percentage is going to work, so we're going to look at one row at a time. So let's first just look at Kentucky. So if I want to calculate my row percentages, I'm going to have to use my actual numbers first. So if we're looking at just Kentucky, we have a total of 400 people from Kentucky. Well, of those 400, how many of them rooted for UC? 40. So I'm going to take 40 out of 400. That's going to give me my row percent there. So that gives me 0.10. So then I'm going to put 10% there. Then of my 400, how many of them are rooting for Louisville? 105 out of the 400. that gives me 0.2625. So we get 26.25% there. And then how many of them root for UK? We have the 255 out of the 400. Which gives me 0.6375. So I'm going to get 63.75% there. And notice those three numbers add up to 100%. Now I'm going to do the same thing for each of my rows. I'm going to do the same thing for Ohio. When we look at doing things for Ohio, going back to our original data here, we have 300 people from Ohio, so I'm going to take 118 out of 300, 116 out of 300, and then 66 out of 300. So take my 105, sorry, my 118 out of 300, my 116 out of 300, and my 66 out of 300. And those will give me my three percentages there. So we get 39.33, 38.67, and a 22. And again, those three numbers add up to 100%. And do the same thing for our other. This time it'll be out of 100, so 26, 32, or 42 out of 100. Get my numbers there, and I'll add them to my table. And again, those three should add up to 100%. So now looking at this table, what can we say? So we look at it one row at a time. So of our 400 NKU students from Kentucky, %, root for UC, 26.25% root for Louisville, and 63.75% root for UK. I'll do the same type of things for each of my other two rows. So of our 300 NKU students from Ohio, (39.33%) root for UC, 38.67% root for Louisville, and 22% for UK. And then lastly, of our students from not Ohio or Kentucky, They're from other states. 26% root for UC. 32% for Louisville. And 42% for UK. So kind of a quick way of summarizing our data. And so notice that we put the sample size for each one in there, but now we can much easily compare the values there. So we can see, probably not too surprising, that if you're from Kentucky, the vast majority are rooting for UK. If you're from Ohio, much less seem to be rooting for UK. More toward UC, a little bit more there. So it's a nice way of comparing things here. But at some point, you want to see, is there a relationship? So in a sense, does what state you are from seem to have an impact on who you root for? So let's go ahead and look at our data from a visual perspective as well. What I've done here first is ignoring which state they were from and just looking at who they rooted for. So that's where you're seeing that 184, the 253, and the 363, which were our totals that we had down here. And so we can look at what's going on here, just looking at what percent do people root for regardless of what state they are from. But we may see something different if we looked at each of the states separately. So that's what the next graph is doing. So we have one graph here for which state they're from. So here's our first graph. If you're from Kentucky, what the breakdown was. And here are those numbers that we just calculated, that 10%, 26.25%, and that 63.75% that we had right here. So you're seeing each of those show up. And then we did the same thing for if you're from Ohio, or if you're from another state. Now, if you're looking at these graphs, do these graphs seem to look different? Oh yeah, they do, right? So this one has a much bigger chunk of green. This one has a much smaller chunk of green. These two seem about the same. Here we're a little bit more even, sort of across things over here. So the graphs do appear to look different. So what does that actually mean for us? That's where this question shows up of, does our response variable, who you root for, seem to differ based upon your explanatory variable or what state you're from? So that's what I'm in a sense saying, by looking at these three graphs, does there seem to be a difference in our three graphs? So if our answer is yes, this means for us that the response variable, here who you root for, is dependent on the explanatory variable. And if our answer there was no instead, we would say the response variable is not dependent. On the explanatory variable. Now what that means picture-wise, I want to make a note of here as well. I'm going to put the three graphs, you know, those could be different based upon the example. So our three graphs look different. What that will also mean is that not all of the graphs are similar to the one big graph. Now going back to look at the pictures, explain what I mean here. So this is the one big graph I was talking about. So if there is a relationship, if I compare this graph to these three individual graphs, they're not all going to look like that initial graph. However, if there's not that relationship, the one is not dependent on each other. The three graphs will look similar. And all similar to the one big graph. And so think about what that would mean. Let's see if that makes sense. So if there's not a relationship, or in a sense, what state you're from doesn't seem to have an impact on who you root for, we should see a graph that looks like this for each of our three state groups that we looked at. Because that would mean didn't really make a difference if you were from Kentucky or Ohio or other. We would all look about like this. Of course, from our example, that does not appear to be the case. We're probably thinking there is a relationship between who you root for and what state you are from. So that's where we're going to start formalizing how to do the test for this. So let's talk about how we're going to do the test for independence. So if they were independent, in a sense, no relationship, what would our percent table look like? Well, we would still have all of our row totals be 100%. We still wouldn't care about the last row there. And the numbers that we get would look like this. So we would have 23% here, 23% here, 23% here. We'd have 31.62% for each of these. And 45.38% for each of these. So first, let's see if it makes sense why the numbers would all be the same. So if they were independent, there's no relationship. What state you're from does not impact who you root for. So whether you're from Kentucky or Ohio or other, same chance you root for any of those three teams. Does not make, the state does not have an impact on that. Now, where am I getting these exact numbers? So these are very particular numbers to our example. Where are those coming from? Well, where you actually see those numbers is actually in our very first pie chart. And here what we're looking at is just looking at who they root for. So if we're looking at independence, we're really just looking at this graph. Which state you're from has no impact, so we can ignore which state you're from, and we just have this graph instead. Right, so how do we actually do this? We're going to need two different numbers, as you see here. We need what's called the observed count, or the actual data. That's what we have at the very first page of the notes. And then we need an expected count. The expected count is the number we would expect to see happen if the variables are independent of each other. Or in a sense, if there is no relationship, how often should we see these certain values happen? A way to think about an expected count is actually thinking about just a coin flip idea. Right? So if you flip a fair coin 10 times, how many heads do you expect? Well, we expect 5, right? So we kind of have this idea of what we expect. Versus we actually flip it 10 times, we're going to get some actual data. We're going to end up kind of comparing these two numbers. But when I have two categorical variables, how do I calculate an expected count? I have it written in two different ways. This first way is the way that most students will use when they're actually calculating it. But the second one I like to talk about from the understanding perspective. In order to calculate an expected count, you just need your totals. We need a row total, a column total, and the overall total. Or we can use our row percentages in decimal forms and a column total. Now when I say the row percentage from decimal form, I'm talking about the one up here under independence. So for our example, I will do it both ways for the first row. So you have another blank table. We're going to fill in expected counts. Alright, so let's first talk about filling in the totals, because one thing that will be true about this table, just like every other table we've had, is that the totals will turn out to be the same. So we're still going to have 400 people from Kentucky, 300 from Ohio, 100 from other states for a total of 800 people. Still 184 will be picking UC, 253 will be picking Louisville, and 363 will be picking UK. So all of those numbers will stay the same. So let's do the Kentucky UC spot. So when I look at this, I need the row total, the column total, and the overall total. So going back to our very first page here. So if we're looking at trying to find the UC Kentucky, we're going to use the 400 for our row total, the 184 for our column total, and the 800 for the overall total. So we're going to take 400 times 184 out of 800, and we're going to get 92, and that's using the first way that formula is written. How I can use the other way is use my row percent, so the 23%, so I'm going to use 0.23 times my column total. So this is also the same thing if I take 0.23 times our 400, and we'll get 92. I'm sorry, on that note, I caught the typo on the previous page. Let me go ahead and show that to you. So this should be the row percent in decimal form times the row total. It should be corrected on your notes, but just to make sure that that's clear there for you. So that number is going to be 92. Then I'm going to find the one next to it here. So I'm going to use my Louisville. So my row total will be 400. My column total will be 253. My overall total will still be the 800. So we get 126.5. Now to find the last number in this row, I could actually just, since I know it adds up to 400, find out what number here makes it add up to 400. Or I can use my formula. So row total 400, column total 363, overall total 800. So we get 181.5. Again, add up those three numbers, we'll get 400. Next, let's do the Ohio UC one. So my row total will be 300, column total 184, overall total 800. So we get 69 there. And now take a moment, pause it here, see if you can fill in the rest of the numbers, and we'll see. Alright, so let's see if we got the same numbers. So all my orange ones are right here. So notice something that changes inside each row is the column total each time that you're doing it here. So a new row total of 100. Same numbers there. And you should be able to add and double check, so all these should have to 400, 300, 100, 184, 253, 363. So they should still add up to be the totals that we see there as well. So that's what we expect to see if they are independent. Then of course we have what actually happened. So it's going to be two different numbers we want to compare. What we expected versus what actually happened. How different those numbers are is what's going to tell us if there's a relationship between our two variables or not. So now we're going to formalize it through our 5 steps for a hypothesis test. So same 5 steps that we saw in our one categorical variable part 2 notes, just now apply to a different type of problem. So let's first look to see how the hypotheses are different. So we no longer have the P showing up in the hypotheses because we're no longer just looking at one categorical variable, nor only looking at one category. We have 2 variables that we're trying to take into account here. So the null hypothesis is the idea of there being no relationship between the 2 variables, or in a sense that they are independent of each other. So the response variable is not affected, so it's independent of the explanatory variable. And the alternative is that there is a relationship, or that the response variable is dependent on the explanatory variable. Or in a sense, we're going to assume there is no relationship until we know that there is a relationship here. Our step 2 is the same as it was before. Again, the only thing that might change is our significance level of alpha there. Conditions, slightly different. We have a random sample of the population or a random sample within the subgroup. You see this subgroup idea happen more often. Really all this means is that you're doing a stratified sample. So I might make sure I take some people from Ohio, a certain number from Kentucky, a certain number from another state, so kind of forcing that stratified sample. And then all the expected counts need to be at least 5. Expected counts, for our example, we had just calculated in our little table here. Then step 3 also has our test statistic in it, and it looks a little bit different here. So we have what's called a chi-square test statistic. So this is just the symbol for a chi-square. This is just the words written out. We're going to see the words when we look at Statcrunch together here shortly. And for that, what we're going to do is we're going to have this sigma. All a sigma means is that we're going to sum things here. So that's what capital sigma means. And we're going to sum our observed minus our expected squared over the expected. Now most of the time we're going to let Statcrunch do that calculation for us. I'm going to show you how pieces of it are done for the first one, but the main reason I show you the formula is to more talk about what it's measuring. So what we're looking at is how far what we observed is from what we expected. So if we expect to see 20 people in a certain group, how many did we actually get? How different is it? So idea of if a fair coin you expect to see 5 heads and you get 6, let's take into account how different those 2 values are. The bigger the difference, the more we're going to believe our alternative. Because that doesn't mean there's a bigger discrepancy going on between those 2. We're going to let Statcrunch, like I said, do this primarily. Statcrunch also can do expected counts for us, as well as row percentages, those things that we've already done together by hand. Then we're going to calculate our p-value. Since we're no longer talking about a z as our test statistic, I can't use that z table that we've used before. So this p-value now is going to just come from Statcrunch. You're not going to have to worry about calculating it yourself. And then we're going to have our conclusion that we've seen before. What else you see right here is how we're going to use Statcrunch, and you'll get a demonstration of both ways. You'll get the data way for the first example that we're doing, and you'll get the summary way for the second example that we'll be doing in the next video, but you'll get a chance of seeing both of those here. That way when you're trying this on your own, you can hopefully see these directions and have it make sense for when you're doing it. So we're going to do it for our example. So the first thing I'll actually demonstrate is how I got the Statcrunch output. So you should already see all this output in your notes. Please note, like on exams, I will give you the output and you just need to focus more on pulling information from it. So let's first talk about reading the output, then I will show you how I got it. When we get output from Statcrunch, we're going to first get this, what we call the cell format. And when we're looking at that, it's going to tell us when I go over here and look at each of these individual cells, so each of these little blocks is called a cell, what each number is. So the first one is the count, or here the observed count. The row percent is the next number. The third number is your expected count. We should have seen all three of these numbers before. And the last one was called a contribution to chi-squared. What that piece is doing this just for that individual cell, because we're going to sum them up then. Then we're given this table, and then we're given a chi-squared test. This is the chi-squared test statistic. So this value that you see here, this is the actual test statistic. And then right next to it you can see we're given a p-value there as well. Degrees of freedom, just let me actually tell you how that's calculated. It's not an important aspect for us, but it's the number of rows in your table minus 1 times the number of columns in your table minus 1, and that does not include the totals. So for example, we have 3 different states that we're from. We have 3 different teams they could root for. So we just get 2 times 2, so we just get 4 for the degrees of freedom. Now let me show you how I got this from Statcrunch. For this example, I'm going to show you from the data perspective. So the first thing I have to do to get from the data perspective is to load my data into Statcrunch, which I've already done. Let me show you, so if you need to do this yourself. So I've generally saved my file somewhere, so I'm going to select a file on my computer. I just browse to find wherever I saved it. So I found my March Madness data set, hit my load file, and then Statcrunch will open with that data set already in here for me. Alright, now trying to follow the directions. We're going to go to Stat, Tables, Contingency, with Data. So Stat, Tables, Contingency, with Data. We have to say which one is the row variable and which one's the column variable. So we organize it that the state you were from is your row variable. The team we root for is the response variable, or the column variable here. And then right here I could click those extra things I wanted. So I clicked row percent, and I control click these to make sure I could get multiple ones. Expected count and contributions to chi-squared. And then I just hit compute. And I get all that output that you already see in your notes. I just organized it in some text boxes in your Word document there. So using the output, let's go through and do our example. So our first step for a hypothesis test are the hypotheses. So my null hypothesis is that the response variable is independent of the explanatory. Here my response variable is who you root for. So who NK students root for. Is independent of state they are from. And then our alternative hypothesis has the same idea except for it's dependent. So who NKU students root for is dependent on what state they are from. So again, null hypothesis is independent, alternative is that it's. Step 2 is our decision rule. So we're going to reject the null and believe the alternative. If our p-value is less than alpha, here our alpha is given to us to be a 1% level. That's going to be 0.01. Step 3 has our conditions in it. So we still have our idea of a relatively random and unbiased sample. We did take a simple random sample. We just took a random sample of 800 NKU students. We don't have any known bias based upon what our goal was. We were interested in just NKU students. The fact that it's just NKU is good. That's who we were interested in. And then we need all of our expected counts to be at least 5. So I'm just going to list all my expected counts. I can get them from 2 different places. We already calculated them here together. So I can use those numbers straight from there. Or I can use my Statcrunch output. And it's that third number that's listed in each of my values here. So we have 92, 69, 23, 126.5, 94.875, 31.625, 181.5, 131.1.25, and 45.375. And those are all at least 5. So we're good there. Then we want to do our test statistic. And although for the most part we're going to let Statcrunch do this, I do want to show you the idea of what the formula is doing. And so I'm actually going to scroll to the output here real quick. And so the numbers I need my actual count and my expected count. And for each cell I'm going to do this. So for the first one I'm looking at my 40 and my 92. And I'm going to use those numbers to plug into my formula that we have here. So our chi-squared is going to be 40 minus 92 squared over 92 plus, that's where the cap sigma or the sum part is. And I'm going to do the same thing for my Louisville, Kentucky, so the 105 and the 126.5. And then I could do that for each of my cells. I'm not going to list them here because let's look at how many we would actually have. So I would have to do this 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So I'd actually have 9 numbers that I'm doing that to and adding together. I'm just going to list the last one here for demonstration. So I'd keep doing that for all 9 numbers. Until I get to the end here. And so kind of I would find these different numbers, I would add them together. And what I should get is my test statistic here in the output, this 139.08. when I add them all together. Now we'll look at this 29.39. You'll actually see that number as part of the output. That's what that last value is, that contribution to chi-squared. So if I take my 29.39 plus the 3.65 plus the 29.76 and keep adding that last value for each of those cells together, that's where that 139.08 number is coming from. For step 4, we just need our p-value. So again, you're not going to have to calculate it. It's just going to be given to you here in Statcrunch. So we're just going to pull that value off for step 4. It's no longer a z, so I can't draw my same picture or use the same table anymore. So that's why we're just using Statcrunch here. We take our p-value, compare it to what we have up here in step 2. That is less than 0.01. So we will reject the null and believe the alternative. So in step 5, before we had 2 interpretations, we are just going to go down to 1 at this point, and we're just going to do at the alpha one. So that's really what a hypothesis test is about the decision here. So our alpha is 0.01 level. We rejected, so there is statistically significant evidence. So notice it's starting the same way. Alpha, whether or not it's statistically significant. And remember, the last part is the alternative hypothesis in words. So there is evidence to support. And notice here our alternative hypothesis is already in words. So there is evidence to support who NKU students root for. Is dependent on what state they are from. Alright, so really up to here, this is all of the new stuff in this set of notes. Your other video, just going to be doing another example of this, getting to see the other way of doing Statcrunch from a summary information as well. So it might be good, since the output is already included in example 2, to try the example on your own before you watch the video, and then you can see if things match up or if we're getting stuck somewhere.